Welcome back. It's another good day with another lecture from chapter 2 of the organic chemistry. So in this video, we're going to go through how to pick the right acid or base whenever we are running a chemical reaction. Okay, in order to move the reaction forward, we will use the pKa. And we said the pKa of the product should be or must be higher than pKa of the reactant. The more gap between them you have, the almost like 100% completion you will get. If they are closer, you will have equilibrium. Okay, so I have a bunch of molecules, and I want to pick an acid and react that acid with them. Okay, so I'm going to say the first one that looks is a base. How do I know? Because there is a negative charge there, and this is going to react with an acid. I don't know what's acid. I'm going to call it HX, and next it will turn to this carbon attached to oxygen with two lone pairs, and then we have a carbon, and carbon is going to accept hydrogen. That means other side, okay, the second component is going to be an ion with a negative charge. So this is going to be the base, okay, and that one it will be the conjugate acid because accepted hydrogen, and this one it will be the acid. The other side it will be the conjugate base. Okay, so let's connect these two as well. Okay, our base, it has lone pair. Okay, it's going to take that hydrogen and it will steal the hydrogen from HX. Now that I know, okay, now that I know the conjugate base and the conjugate base in acids, I'm going to assign the pKa for my acid and the conjugate acid. Okay, so I'm going to say the pKa of the acid is something around 19.3. Okay, what's going to be the pKa of the acid? Okay, so the conjugate acid is 19.3, and I'm looking for the acid. I want to know what's the pKa or which pKa for HX I can use. Okay, anything that you need, like anything that you're using must be, okay, must be less than 19.3. Otherwise, the reaction is not going to be moving forward. So anything that has a pKa less than 19.3, we can use it. Okay, let's go back to the table. Okay, can I use, for example, water? Yes, it's possible. Okay, but you want to have the reaction to go through 100% completion. Maybe you should use that one, or like say go with this one. Okay, it doesn't matter really. Anything that is less than 19, it will be fine. So anything from this table is acceptable. Okay, listen carefully. Anything from this table is acceptable, but let's have a big gap between 19 and the acid, and I'm going to use that one, the carboxylic acid. So I'm going to use, okay, the acid that I'm going to use, it will be this. And the pKa for this acid, it says the pKa for it is 4.75. Okay, I said any acid from that table is fine, but I'm going to just pick this one. Next, okay, we're going to react this one with acid and see what will happen. If we do it, remember, oxygen has two lone pairs. So oxygen with two lone pairs is going to go after this hydrogen, and it will give us such a compound. We will have hydrogen attached to it. We'll have only one lone pair. That means we have a positive charge here. Okay, what else? We get X minus 1. Okay, this is going to be the base. And that one, it will be the acid. So this is going to be the conjugate base. Sorry, conjugate acid, my bad. Conjugate acid. And that one, it will be the conjugate base. Okay. And what else? I have this one. Okay, so what's going to be the pKa? Okay, let's see. pKa of the okay, pKa of the product. I'm going to write it here. Okay, so pKa of this product, the conjugate acid, if I go to the table, is minus 7.3. Okay, minus 7.3. Okay, so it will be minus 7.3. Okay, you wanna give a proton to acetone, like starting compound or the base, we call it acetone. If you want to give acid to it, you need to use really strong acid, something that has pKa less than minus 7. So pKa of HX must be less than 7.3. Okay, less than that number. And again, if we go to the table, this is the only acid that we have. It will be sulfuric acid, and this is going to be the correct answer for it. Okay, so only acid that we can use, it will be sulfuric acid because it has a pKa of minus 9. Okay, so our acid HX will be H2SO4 that has a pKa of minus 9. Okay, another example. Okay, we're going to react this one with HX. Okay, clearly this is going to be the acid, and this one, it will be the base. Okay, the base is going to go after after H. It will take the H from it, and it will generate such a compound. Remember, your oxygen has 3 lone pairs, and that's the reason is negative. So now we're going to have only 2 lone pairs and 1 hydrogen attached to it, plus we get X minus 1. Okay, so this is going to be the conjugate acid, and that one will be the conjugate base. Let me move it a bit down. Okay, that's our conjugate base. Okay, now I want to know what's the pKa of the product. The pKa of the product is equal to, again, based on the table, this is our compound that we're talking about, it is 4.7. Okay, 4.75, my bad, 4.75. Okay, so I'm going to write the pKa for it. pKa is 4.75. Okay, pKa of the acid HX must be less than 4.75. Okay, so anything less than 4.75 is possible. Okay, so this is going to be the cut. Okay, this is going to be the cut. Anything higher, okay, anything in this region is possible. So anything up, we can use it. Okay, of course. Okay, of course, the bigger bigger gap you have between 4.75 and the acid that you pick, the higher completion and higher ratio of completion you will get. Okay, can we use, for example, HCl, which is minus 7? Yes. Okay, so I can use HCl, for example. Okay, of HCl, which is minus 7. And and that's going to do the job for us. Okay. Another example. Okay, so let me erase that part. Okay, prepare it for next example. Okay, we have this molecule. We're going to treat it with an acid, HX, and we're going to get carbon that's attached to another carbon through a triple bond, and then we will have hydrogen there. Okay, you remember that you already have 1 hydrogen here. Okay, they did not show it. It doesn't mean it does not exist. You do have 1 hydrogen there. Okay, and the hydrogen that I'm going to highlight, this hydrogen, it will show up there. Okay, and that hydrogen, we already had it. We had that hydrogen before, and that's the reason I'm not talking about it. Okay, so I'm going to say the pKa for this is around 25. This is your conjugate acid. And of course, you get X minus 1. That's going to be the conjugate base. Okay. And this is going to be my base. And this one, it will be the acid. Okay. So pKa of our acid, HX, must be less than 25. Okay. So how about something that it has pKa around 10? Okay, I want to keep the gap really big between them, so to be sure that this is 100% completion. Okay, 100% completion. So how about this? Let's go with, for example, pKa of HX. That's something around, say, 10. Okay, this is the table. We go back to the table, and so can I use, for example, this one? Okay, and that's going to be a phenyl. Okay. Okay. Phenyl. And so that's going to be one of the options that we can use. Of course, you can use water as well. But I'm telling you, like the smaller number that you use, the better. Okay. So let's pick, for example, phenyl. But anything from this table is acceptable. So anything from this table is acceptable because the pKa we're dealing with is a 25. And all the pKa's we see here, they are less than 25. So anything is possible. Okay. And I'm going to use phenyl. Okay. And then phenyl, it has pKa, I said around, I believe it was around 9. Let's double check it again, 9.9. Okay. So let's use phenyl, which is 9.9. This is our acid. We have a ring that it has oxygen attached to it. H, we have 2 lone pair on oxygen. And of course, we have 3 double bonds there. And the correct name for it, it will be phenyl. Okay. So I hope this lecture is going to be useful and teach you how to pick the right acid for any chemical reaction. Thank you very much, and I will see you soon.